Welcome to this podcast on server and storage trends. My name's David Pike, otherwise known as Connector Geek. I am joined today by Chuck Crandley and Bill Wilson from Molex. Welcome, chaps.
Hi, David. How are you?
It's good to have you with us. So today we're going to talk about servers and we're going to talk about storage and data. Data is the raw material of the future. Everything we do, whether it's manufacturing of goods or how we get to work, is going to use data to a much greater extent than ever before. And this is enabled by the internet and specifically by the wireless connectivity that we can now enjoy with things like 5G and mobile phones, cell phones. It means that we are all going to be connected far more than we ever have been before. But the important thing to remember is that all of this data needs to be processed and it needs to be stored. Many of us probably have heard of data centers, the hubs of communication that are forming the backbone of the internet, but they form just part of the picture of this worldwide network of data that we're having to deal with. Data is going to need to be processed and stored in servers, and they could be found almost anywhere in the modern world. And so that's what we're going to talk about today. We're going to talk about how this data is managed, some of the latest innovations in the technology, and we'll look at some of the challenges that face designers today when they're trying to implement some of these latest systems. And so I'm going to open up with the first question both to Chuck and to Bill and say, what are these latest trends and developments in the world of server and storage?
Sure, David, this is Bill. I can jump in and kind of talk to that first question. I mean, really what we're seeing in the server storage area is just, as you mentioned, just more data that's being stored and processed and transferred and transmitted at higher speeds, and honestly trying to do all that with minimal errors in the overall transmission of the data, right? You want to do it fast and you want to do it efficiently. Data centers and this comes at from a big level, from a data center level down to the individual devices and even the subcomponents that all need to kind of be synced up to make sure they're all executing that same goal and pushing everything towards the future. So some of the things you're seeing from trends are just redundancy, which I think we'll talk about, and modularization, and then optimizing processes within the rack and within the data center by implementing specialized boxes for more unique tasks, such as like GPUs, TPUs, accelerators. And what these do is really help offload specialized tasks from your standard rack servers that aren't maybe not optimized to handle those unique tasks and pulling them up into separate boxes. And then, Molex plays into that by creating the ability to interconnect those boxes and do it in a way that maximizes performance. And then all of these things that we're talking about, everybody's driving towards lower energy consumption, right? Because you can't just continue to exponentially increase the amount of energy and heat and all of these other things that are generated from this data transfer and data processing. So that's another main thing. And a lot of that comes back to the chip companies that are working, as I said, at this kind of subcomponent level down at the board, and those companies that are developing these next generation chips really drive a lot of this development forward and kind of kickstart each new generation of product as it is released to the market, continuing to provide more functionality in every square nanometer in each new chip release. And then the hardware design kind of follows after that, right? It's basically structured to support these next generation chips and to enable all of the technology advancement that happens when these chips are released into the market and available for purchase.
That leads me to a question. I wasn't necessarily going to ask this question, but it's raised something in my mind. You've talked about these boxes and these specialized processing units that are around the place. So to somebody who isn't necessarily too versed in the whole architecture of this, to me, is a server is a big rack, a big fridge worth of servers that work together. But the network you're describing, or the infrastructure you're describing, is that, yes, sure, that plays a part. You've got this big fridge of devices, but you're going to have smaller devices that are maybe placed closer to where they're going to be used. Am I getting that right?
Yeah, so I think every data center is structured differently depending on the needs of what it's actually trying to accomplish, and the balance between servers, storage, boxes, accelerators, networking equipment is different depending on the data center and what the end customer is looking to accomplish with the data center. Now, some of these are shared resources between multiple companies at times. I think that's probably more rare these days because these major companies want to just have these dedicated server data center farms just all for themselves, right? And so, yeah, as you kind of mentioned, there's optimization that can happen within the data center of trying to accomplish certain tasks by having a certain balance of hardware and having it located and optimized based on the tasks that are needed for that specific either set of hardware or for the whole data center itself.
And so from the Molex point of view, you're going to be working on all sorts of solutions that are solving problems within these trends. And you've got to be just as up with the latest technology as you're talking about the chip manufacturers. You've got to work hand in hand to provide solutions for these high speed requirements.
Hi, David. This is Chuck. So, yeah, to your point, in regards to what solutions we're coming out with to tackle these trends, it really comes down to improved SI, reduced energy consumption, like Bill just touched on, but also exploring points where loss is located in the current server designs. So, particularly in the interconnect and cable that we can touch. So, if you look at things like such as PCB termination that's in cable assemblies today, how do we either optimize that or just flat out remove that from the channel to try to improve performance and take out points of loss? With our cables and different products, some that Bill is developing, some that I'm developing as well, between chem riser cables and near stack products, it helps drive out that loss and meet next generation server applications.
So the customers are demanding obviously that reduction in loss, but I imagine at the same time they're demanding greater functionality be packed into everything that we're doing. So I assume density is becoming a big thing to talk about.
Yeah, this is Bill. I think that's definitely the case. As you mentioned, maximize the performance in as minimal of a space as possible, right? And I mean, to some degree, there's a limitation there on physics, right? And I explain this both internally and externally to engineering teams is that all these things kind of play together, whether it's XY density on the board or whether it's Z height off the board, or SI performance, right? Because the closer you get all of these contacts and structures within the connectors and cables to each other, the more signal interference you're kind of inherently introducing. So that's one of the challenges for us is to, maximize that density, but not at the expense of SI, or maximize the SI, but be willing to accept a slightly less dense solution, or a merging of both of them, right? Where you kind of settle on an acceptable density for a certain SI performance. So it's just understanding exactly what customers are expecting and trying to put our best foot forward. And I mean, the other one thing that I wanted to mention too is manufacturability, right? You can't do all of these things and develop a connector in a CAD system and then not actually be able to manufacture it in the real world. I think that's another thing that we could touch on even for Molex, how we're working on solutions to meet these trends is making sure that we can not only keep up with the technical aspects of them, but also ensure that we're developing a product that is manufacturable and that we can ramp and supply the market with the capacity that's needed of the actual products that people want to buy, right? Coming up with a very complicated product that is very dense and has good SI, but we can't make it, or we can't make it in volume, is something that doesn't really set ourselves or our customers up for success. So that's another major thing that we focus on and are currently focusing on is that design for manufacturability aspect and coming up with a design that's easily able to be manufactured in high volume.
It's interesting actually. We look at that question of ideal density versus the ability to actually make it. Are we approaching the limit of density? Are we getting to the point where we simply can't make connectors and other devices more dense, or is it a case that manufacturing processes will always evolve to try and bridge that gap and get to one level smaller, as it were?
That's a good question. I mean, that's where we're kind of pushing the boundaries of what we think is possible, right? I mean, there was discussions 10 years ago of, is copper going to make it to 25 gig? Is copper going to make it to 56 gig? Is copper going to, and now we're starting to even look at things like, 112 gig and 224 gig with copper solutions. And so it's always an evolution of how small can you get things and how small can you get things to perform reliably and at a high level. It's critical for us to understand what our manufacturing capabilities are, what our suppliers' manufacturing capabilities are, and not just at an end product level, but at a component level too. So, can we hold these tolerances? Can we make things this small? Can we use material that thin or that thick in this type of an application? Are we able to mold around that type of a feature? I think we've realized over the last 10 years that we've been able to push things a lot further than maybe originally expected, but where that critical mass point falls is still, I think, TBD. I mean, I think we're still trying to continue to move things as far forward as possible with the technology we have. And so, will manufacturing continue to evolve? I would assume that the answer is yes, but I'm assuming there's also a limitation on when we can no longer do the things we've always been accustomed to doing. And I'm assuming that's probably sooner rather than later, just because of the fast advancement of data rates and other technology that we've seen over the last several years.
Hi, David. This is Chuck. In addition to Bill's comments on density and continuing to reduce the envelope, I think you really have to think about what drives the industry and what's driving the application. So a lot of what we see in the server space is driven by an MSA or an industry standard, as well as influence from the silicon providers. So much like Moore's law continues to attribute to more dense chips and more packed within the server and CPU space, we're seeing a push for that within our products as well. You have things like onboard modules and interconnect within the substrate. But then you also have trends where you have possibly not a need to get denser, but more flexibility. So you would have something like a floating riser instead of a fixed riser. So you're taking the interconnect and cabling off the board and allowing for more unique layout within the riser assemblies coming in and the I/O coming into the server. Density is key in a focal point, but there's also other areas where people are looking to get creative, both with performance, but also the layout of their servers with flexibility and riser location.
So what I'm taking from that is that it isn't just about just getting smaller. It's about working smarter and getting the better results from the architecture in a different way. I hope you forgive me for putting you both on the spot on that. Manufacturing of connectors, the processes of how these things are put together and the materials used, that is one of the key things that I'm always interested in. And to see this rocket ship speeds, frankly, being used in connectors. And as you say, some years ago, not too many years ago, we were sitting here thinking whether or not copper was going to be able to perform at this level, and yet we've developed techniques, we've developed new materials and new ways of handling the materials to be able to provide this kind of performance. So thank you very much for that answer. I find that absolutely fascinating. I do want to step back ever so slightly. We talked about SI, we talked about signal integrity, and I'm guessing for those who haven't necessarily come across signal integrity, it's hard to overstate the importance of that when we're talking about these really high data speeds. An interruption in a signal for the briefest of fraction of a second is going to cause a huge amount of loss of data. I take it signal integrity is key to the kind of things that you're working on.
Yeah, hi, David. I can handle that. This is Chuck. Signal integrity is going to be critical in these applications, especially for what I work on, which is primarily edge card and cableized designs, hybrid cables. With that, you could have potential decisions made on something as small as a quarter dB of loss based on whether or not a customer could change their architecture and layout. So it cannot be overstated enough how important SI is.
Yeah, and then David, I'll jump in there really quickly too. And I mean, neither Chuck nor I are SI experts, but we deal with it every day. The SI question, and I think David, you and I talked about this on the last podcast about just trying to make sure that data gets from point A to point B in a way that can be received and interpreted, on that point B. What information you're trying to send can be accurately interpreted is the key here, right? The actual integrity of that signal and making sure that the information is correctly processed. And that's, point A to point B can be from chip to hard drive or vice versa within a box. Or, I mean, it can honestly be from chip to a different chip in a completely different system or across an entire data center, right? So when you're looking at all of that, it's a huge undertaking to make sure that your ability to transmit that data is correctly identified at each stage of the signal. And Molex really plays into some of that, right? I mean, I guess from Chuck and my perspective, we're mostly inside the box with the stuff that we're developing, but Molex, very broad product offering in the server and storage space, where we then play in the external cabling, we play in the network cabling, we play in the interconnect between data centers and out to the network as well. So, we touch a lot of that. And so just being able to understand it both at a very finite level, but also at a larger system level is very important for us and for our ability to support the data centers.
And when we were planning for this call, we were talking about some of the technology that Molex can offer that combats signal loss. And we were talking about things like optical connectivity, we were talking about things like linear amplifiers and retimers, and they're the devices you're talking about, but they're very much more active led, aren't they? And you're looking more at solutions within the server,
right,
and trying to avoid the need for that active technology.
Correct. Yeah. I mean, active technology, as soon as you say actives, you should hear a bunch of dollar signs pop up in the background. And not that that's necessarily a bad thing if that's ultimately what's needed to accomplish what you're trying to do. But, stretching copper to be able to meet those needs without having to go to optical, or trying to implement a cable assembly as opposed to putting a retimer or redriver on your board, which can add up cost pretty quickly. And there's other related benefits as well in terms of, as we mentioned, energy savings and thermal dissipation and things like that. But yeah, I mean, ultimately our products, the stuff that Chuck and I are working on specifically, our goal is to really remove the need for those extra active components and optical technology. That's a critical part of what we're trying to accomplish for sure.
And that brings us on to the subject we mentioned it, or you mentioned it earlier on. We're talking about modularization, and I assume that's part of the flexibility that we're trying to provide to architects here. I'm guessing that keeping away from those active devices means that your systems are that much more adaptable without having to worry about those power and thermal considerations when it comes to reorganizing things. If we can touch on modularization to begin with, I've heard it as a solution for flexibility and an easy way to upgrade systems, but can you give me a slightly clearer idea of what modularization is when it comes to this server application?
Yeah, hi David, this is Chuck. Yeah, at the individual server level, one of the key points of modularization is the ability to replace various riser and add-in cards in a box while really keeping the same base compute block. And what I mean by that is it provides that functionality at the panel. So as I touched on earlier, you could have floating risers where they're off the PCB and mounted. So it's essentially a riser cable, or a fixed riser where you're putting additional add-in cards off of fixed PCB coming off the motherboard, or you could have a combination of both. So it adds for that functionality there. With that, and some of the value propositions you have there is the ability to easily replace or customize the server chassis. It also adds for different functionalities. So if you want to have anything from a standard NIC, smart NIC, or even a GPU, you can interchange those and adapt your server as needed. I think more at a rack level, what you're seeing is enabling communication. It's going to take you from server to server or server to accelerator. Probably a good example of this would be, what the Open Compute does with their UBB module and putting those accelerators to server applications, or even with CXL and some of the memory clustering that's happening there as that gets adopted.
And so when we're talking about upgrading, we're not necessarily talking on a minute by minute basis, but we are in a situation where people are having to future-proof their designs to a certain extent. And this is the technology that's going to be able to let them do that, isn't it?
Exactly. So this is the ability, as you're developing a system and you're doing your front end architecture, you can develop that with the knowledge that you have the capability to add these features in, so you can tailor them on an as need basis.
And bringing it back to Molex very clearly, Molex connectivity is going to form a key part of how that works, isn't it?
Correct. So as an example, the riser cables, the PCI Chem riser cables that I'm working on today are an example of where you're taking that modularization. You're enabling the location of the riser cables in a different aspect, so you can pack more into the server. Another example would be fixed risers, where you're taking a product that Bill develops with our near stack and then cabling that off of one of the fixed riser cables down to the motherboard, wherever it needs to be located. So it adds that functionality combined with that modularization.
The Molex portfolio doesn't really stop there. So I know that you've got a quite an enormous range of products that will help with this server and storage application. Give us a few ideas of some of the products and some of the ways that you're actually addressing these. You've mentioned NearStack, but what are the other products that people need to be looking for when looking at this type of situation?
Yeah, David, this is Bill. I mean, I think from what we've seen in the market and kind of the things we've talked about here, I mean, when you hear modularity and you hear upgradability, I mean, all of those things really should just kind of make you think of pluggability, right? Making something that's replaceable and can be changed out if needed to be upgraded, et cetera. So, anytime we hear these terms, it's great for a connector company or a cable company, right? We want to provide solutions across the board of integrated products that allow you to not only service today's needs but give you that path towards what's coming next. We've done that with for example, a project I worked on several years ago was with a modular server that was backplane oriented, or actually removal of the backplane from that chassis. So no longer did they have a backplane that was limited to 12 gig or 25 gig. The backplane was completely removed, and all of the high-speed connectors from the front of the system and the back of the system mated in the middle, and those boards on either side of the system could be upgraded individually to the to the speeds, to the interconnect that was needed to accomplish that next generation. So, historically, these chassis are out in the field for sometimes 8 to 10 years. And they have a very hard stop at what they can accomplish because of some of the connectors and technology that were used inside of them. So this new strategy in these products, which was our Impel Plus Ortho Direct family, allowed our customer to create this upgradable system that wasn't limited by legacy technology, but was fully modular and able to be upgraded as needed.
And so in that case, we're looking at the old-fashioned backplane, as I understand it, is a dinosaur, a thing of the past, and the kind of cabling systems that you're able to offer now can far outstrip those backplane systems in performance.
Correct. Yeah, from a performance level, that's definitely the case, and it's really dependent on kind of cost and how critical that is to achieve. Because if you put a ton of Twin-X inside of a system, there's definitely some benefits, but there's disadvantages as well. Just typically from a cost perspective and from an implementation perspective of installing all of that. So, I mean, we work with our customers every day on these types of questions to ensure that the solutions that they're looking for are the right ones, right? We want to make sure that they have all the information that they need, they have all the tools in their toolbox to make the right decision for their products. So they sometimes look to us for guidance on whether, from a connector and a cable perspective, that they're going the right route, right? I mean, they have to. We trust them as the experts in their hardware development and product launch, and they trust us to give them expertise on connectors, cables, other integrated solutions that that they may be looking to implement into their systems.
I think actually that's a fantastic takeaway from our discussion, is that there are people out there who are experts in their own field, but when it comes to developing this kind of connectivity solution that will make the most of their own systems, Molex is ideally placed to be able to offer a combination of things. We've talked about active devices, we've talked about passive copper systems and how they are being developed for this latest generation of electronic systems with speeds that, as we've talked about, the kind of speeds that we're talking about now with 224 gigabits on the horizon. That's a quarter of a terabit a second nearly on one channel. This is science fiction stuff, really. So we're talking about a company that's able to develop all these different solutions and deploy them into the field for the customer, and to make the most of the future proofing that we've talked about. Again, it gives the confidence that the system can cope with the demands that will be coming down the line, and coping with the amount of data that we're going to be seeing in this modern world. Literally everything that you can think of, from your refrigerator in your kitchen to your car to your mobile phone and to all the systems that you would use at work, data is going to be key. I think that's probably a brilliant place to leave this conversation. I'm fascinated by the way that Molex is solving these problems, especially when we talk about the idea of not always having to rely on active solutions to be able to deal with these high data speeds. So Thank you very much to Bill. Thank you to Chuck. This has been a fantastic conversation about this kind of technology. These servers are going to be more and more a part of our lives. And for anybody listening, Molex is ideally placed to be able to help you out to deal with that data speeds that you need to be handling in the future. Bill, Chuck, thank you so much. It's been brilliant to talk to you.
Yeah, thanks a lot, Dave. I appreciate the time and look forward to talking to you again.
Yeah, Dave, thanks for having me.
And thank you everyone for listening. This has been a podcast to talk about server and data storage solutions with Molex. We look forward to talking to you on the next podcast.